Hey guys, welcome to day 41. Today we're going to take what we learned last class when we learned about direct and inverse variation, and we're going to add in some word problems. Okay, the first one says that direct variation word problem. So it's going to be important that you have a highlighter because I find it's easier to keep organized when you have a highlighter with a word problem. Hooke's law for an elastic spring states that the distance a string stretches varies directly as the force applied. Okay, there's our keyword, varies directly. That means that we're going to be using the direct variation, y equals k times x. Okay, that's going to be the equation we're going to use. All right, the distance the string stretches, so we're going to let d be the distance, okay, varies directly as the force applies. So we're going to let F be the force. Okay, and because it's varying directly, instead of y is equal to kx, we're actually going to say d is equal to k times f. Okay, so the distance varies directly as the force. Okay, it's easier to keep organized when you have variables that begin with what you're looking for. Okay, step 2, we use the information given the problem to find the value of k. So in the in the word problem, it says if a force of 160 newtons. So the force is 160, so your F is going to be 160. So right here, we've got 160 is your F, and your K, we don't know, okay? And then our distance is going to be 5 centimeters. So we then solve for K, and that's how we get 1 over 32. Once you get your constant of proportionality, you need to, in step 3, rewrite the equation from step 1. So instead of d is equal to k times f, we're going to rewrite that as d is equal to 132 times f. All right, then we use the equation found in step 3 and the remaining information given in the problem to answer the question asked. In this case, you need to find d because it's saying how much, it says if a force, how much will a force of 368 newtons? So we know our force is 368, and we were trying to find out how much will the force stretch the same strength. So we're looking for the distance. So your d is equal to, when we take the 132 times the 368, and that's how we get the 11.5 centimeters. Okay, now similar in this example, we've got an inverse variation word problem. It says the time it takes to get to campus varies inversely as your driving speed. Okay, so varying inversely, we're going to think of y is equal to k divided by x. Okay, and the time it takes, we're going to let t be the time. Okay, and it's going to take and we're going to average 20 miles per hour. So the time it takes to get to campus varies inversely as your driving speed. So the time varies inversely as the speed. So let's let s be equal to the speed. Okay, so we're going to take these two new variables and substitute them in for y and x. So since the time is varying inversely, it's going to be t is equal to k divided by s. All right, we then use the information given in the problem to find the value k. So it says it takes 1.5 hours to get to campus. So your time is 1.5, and you're averaging 20 miles an hour. Your speed is 20. So that's how we get this line right here. We then multiply by 20 here, 1.5 times 20, and that's how we get a k of 30. All right, the next step, we then take this k of 30 and we actually plug it back in, and that's how we get t is equal to 30 divided by s. All right, now we're actually going to use the equation found in step 3 and the remaining information in the problem to answer the question. In this case, you need to find the time when the speed is 50. So we just plug in s is 50, and that's how we get how many hours. Okay, so let's do an example here. A man has to take a bus to and from work each day. The cost in dollars varies directly. Okay, so his cost, C in dollars, varies directly as the number of days. Okay, so varying directly, we're going to think of y is equal to k times x. Only now, we've got, let's let c be equal to the cost, and let's let d be equal to the number of days. Okay, so instead of y and x, we're going to have our cost is going to be equal to K times the number of days. It says it costs him $3 per day. So there's our rate of change, our $3 per day. So that's actually our constant of proportionality. So our K is given in this case is 3. So we can rewrite this equation as cost is equal to 3 times the number of days. All right. It says how many days does he commute if it has cost him $36? Well, we know the cost here is 36. So we can go right to where the C variable is, and we're solving for the number of days. So to do that, we just divide by 3, and we get 12. So we get 12 days as our answer. All right, the next one says the amount of money earned on a job. Okay, so the amount of money earned on a job is directly proportional. So directly proportional is another way of saying a direct variation. Okay, to the number of hours worked. Whoops. To the number of hours worked. So let's let, okay, M be equal to the money and H be the number of hours. All right, directly proportional means Y is equal to KX, or in this case, we're going to say money is equal to K times the number of hours. We're going to use the data that's given. If $36, so our money is 36, is earned for 8 hours of work. Okay, notice I just plugged in your 8 for your H, and then we're just going to solve for K. All right, when we do that, our K is actually equal to 4.5. All right, so we then take this K, plug it back in here, and we get our money is equal to 4.5 times your hours. Okay, the rest of the question says how much is earned for 30 hours of work? Okay, well, we know that H is 30, so we're just going to figure out our money. 4.5 times 30, so our money is going to be $135. All right, so $135. Okay, the next one, it says the planting time T varies inversely with, let me move this over a little bit so we can see it. The planting time T versus inversely, so we're varying inversely, okay, and the time, planting time T, so we're letting T be the time, and we're varying inversely, so we're going to think of Y is equal to K divided by X, and it's inversely with the number of people who volunteer. So let's let P be equal to the people. All right, so let's rewrite the equation with T and P instead of X and Y. So time T actually varies inversely with the number of people. Okay, the group estimates that 20 people, so we have our 20 people, okay, working for 200 hours. So our hours would be 200. All right, so we're actually trying to find our K. So 200 hours, our time, is equal to K divided by 20. If we multiply both sides by 20, we end up with K is equal to 4,000. Okay, once we have our 4,000, or our K, we can plug it back into this equation, and we can say that time is equal to 4,000 divided by the number of people. The rest of the equation says find the total time it will take. So we're looking for the time. It takes a group of 32 people to plant. So we're looking for the time, but we know the number of people. So it's 4,000 divided by 32, which will give us an answer of 125. So it's 125 hours. All right, moving on to number 4. All right, it says the number of calories in a carton of milk is directly proportional. So we are directly proportional, and it's the number of calories. So let's let C be equal to the calories. And it's directly proportional, so Y is equal to K times X to the amount of milk. So the amount of milk, let's like M be the amount of milk. Okay, in the carton. If there's 160 calories in an 8-ounce glass of milk, so let's write this. We're going to say C is the calories is equal to K times M. All right, we know there's 160 calories, so C is 160. We don't know our K, and our milk is 8 ounces, so let's put an 8 there. If we divide both sides by 8, we get K is equal to 20. Okay, so our constant is 20. We plug it back in here, so our calories would be equal to 20 times however many ounces of milk. All right, the second part says find the number of calories in a 15-ounce glass of milk. So we know how much milk, and we're looking for the calories. So we just plug it in for M, and we end up with calories is going to be equal to 300 calories. Okay, number 5. All right, number 5, a theater company plans to hire people to build a stage set. The work time T in hours varies inversely. Okay, so let's get our highlighter. We're going to vary inversely. Okay, the time, so let's let T be the time, and it varies inversely with the number of people. Okay, P is going to be people. All right, let's set up our equation. So because it's varying inversely, y is equal to k divided by x, or let's use our new variables. The time is going to vary inversely with the number of people. Okay, so from here, we know that the company estimates that 25 people working for 300 hours can complete the job. So 300 hours is equal to k divided by 25. So if we multiply both sides by 25, we end up with k being equal to 7,500 or 7,500. Okay, we take that, we plug it back into our equation. Time is equal to 7,500 divided by the number of people. How long will it take in hours if the company hires 30 people? Well, all we do is let P be 30 and say time is equal to 7,500 divided by 30. Our time is going to be equal to 250 hours. Okay, thanks guys.